Yes, welcome to the last Zoom call. You're here reading this. You've made it. Excellent person. You're a trooper. You're a real one. Coming all the way out here. Good job, guys. How many people are here today? It's like 6 people. 1, 2, 3, 4, 5, 6. Yeah, 6 people. All right. So it's just a total review of the whole thing. All right. So rates and ratios. I guess I didn't make it too clear at first lesson, but a rate is a comparison between two different measurements or units, and a ratio is a comparison between two different quantities. And so the key difference you want to know is just basically ratio is only numbers, like purely only numbers, and a rate is actual measurements, like you actually have to put units in it. And obviously a unit rate is a per 1 unit compared to something else. So in order to have a unit rate, you got to have a 1 in numerator, like a 1 miles per hour kind of thing. Can I not? I can't annotate? I guess not. Okay. And then you guys know the drill. All can be written as fractions or with a colon or with words, like 4 to 3, 4:3, 4/3. You guys know the drill. All right, next. Operations of fractions. You guys know this. Multiplying fractions, straightforward. You just multiply both numerators and denominators across. So if you had a over b times c over d, then it would be a times c over b times d. You can also cross simplify if both numbers are diagonal to each other, share a common factor. It's just a way to simplify your product faster. You don't have to cross simplify, but make sure if once you get your product, you do simplify. So cross simplifying is just a faster way. And then dividing fractions is literally the same thing as multiplying fractions, except you make the second number. Wait, did you still see the first slides? Okay. Except you make the second number into its reciprocal. And then this should say multiply. Then you multiply. Why can I not annotate on this one? Oh, because I'm not enabling editing. Hold on. Yeah, today is super chill lesson. We just do stuff. There you go. Whoops. Okay. Okay, so the first slide, yeah, so rate, it's like miles per hour, because these are two different measurements. You can measure miles, you can measure hours, and ratio is like 4 to 3. It's just numbers, only quantities. So yeah, key difference, rate includes actual units of measurements, and a ratio is just simply only numbers. That's it. And then, like I said, if you had multiplying fractions, it would be AC over BD. Nothing too complicated. If A and D had shared a common factor, then you could cross simplify. If B and C, same thing for B and C. And then dividing, let's just say multiply. Multiply. I made this in like 2 hours. I made this like literally 2 hours ago. So dividing fractions, similar to multiplying fractions, you just make the divisor or the second number into reciprocal. So if you did A over B divided by C over D, you would turn that into A over B times D over C. This is reciprocal. Remember, reciprocal is you just flip the denominator and the numerator, and you just simply multiply. And then once you start the multiplication, you can also cross simplify. You can also cross simplify, just like normal. But yeah. All right, order of operations. I bracketed these two for a reason. I'll tell you guys why if you guys remember. But remember PEMDAS, parentheses. So anything you do in parentheses first, then exponents. So you do inside, then multiplication times, and then division times divide, and then addition, divide plus, and then subtraction times divide plus minus. But how I learned it, the reason why I grouped these two together is because if you see, like let's say you had 4 times 3 divided by 2, if you see the multiplication and division together, or you've had 4 minus 3 plus 2, How I learned it is that you just do it left to right if you see the same grouping, the same type of operation. So this would be 12 divided by 2. And then this would be 1 plus 2. Now, if you followed PEMDAS, I don't know, other people also follow PEMDAS in the exact order. I learned it where you just do it left to right if you see the same pair of operations. But if you did it in the way if you strictly followed PEMDAS, then you would get, let's change this actually. Divide by 2, divide by 3. See, in this case, how I learned it is you just divide left to right. But if you strictly follow it, you would do division first. So 2 times 3 is just 6. Or sorry, if you didn't follow it, but if you followed it strictly, you would do 4 divided by 6 because you would multiply the 2 times 3 first because multiplication comes first. I don't know what exactly is the right way. I think the left to right way is the correct way because if you punch it in a calculator, it'll do the left to right method. It won't follow the strict method. So I'd say do the left to right, my personal opinion. Likewise, if you did the, if you had like 4 minus 3 plus 2, instead of doing it left to right, you do addition first. You have 4 minus 5, which is -1. So obviously you get different answers based on a different order you do it, which is why order of operations is important. So do the left to right method. Okay. All right, this looks a little interesting. This looks a little confusing, but it's not that bad. Okay, so operations with negative numbers. So if you have a positive number and you add it with a negative number, it's the same thing as subtracting. It's literally the same thing. So if you had 4 plus -2 is equal to 4 minus 2. It's the same thing as just subtracting 2 positive numbers. That's what I mean for this first one right here. So positive plus negative equals positive minus positive. If you had a negative plus a negative, you would get a bigger negative. So if you had -4 plus -2, it would make you a -6. You just basically add on the negatives, the values, you add on the values of the numbers and you just plug in the negative. It should be negative. So you get a bigger negative. Subtraction, just know that when you subtract the negative number, which looks like this, it's the same thing as adding a positive number. So let's just walk through it. So if you add a positive number and you subtract, isn't negative just negative e? What do you mean by that? Forget e. Oh, isn't negative just negative? That's positive. It should be plus. Because if you, this equals positive. So if you have negative is positive. I know I mean the first one. Addition. Well, since you have minus negative, you just be adding, no? It's just adding the positive number. Negative plus addition, negative. Oh yeah. I'm just saying. Oh yeah, you're talking about this. I'm just saying it makes a bigger negative. Yeah, don't ignore the signs. Just saying it's a bigger negative. That's why I put 2 negative signs. Just to show you. It stays negative. Just makes a bigger negative for addition. All right. Anyways, so if you add a negative, if you have a positive number and you subtract it by a negative number, it's the same thing as adding a positive number. So if you had 5 minus -5, it's the same thing as 5 plus 5, which is 10. They all equal 10. Likewise, if you had a negative number minus a positive number, it's the same thing as adding 2 negative numbers, like I said up here. So you would get a bigger negative. So if you had -5 minus 5, that is equal to -5 plus -5, which equals -10. There you go for this one. And then this one is if you had a negative number minus a negative number, it's a negative number plus a positive number. So no, when you see this pattern right here, when you see anything like this, like that, that becomes, so let's say y, that becomes y plus x. These 2 negatives turn into a positive. And that's a general rule of thumb you should know about negatives. So if you had -5 minus -5, that would give you 0. Because that's -5 plus 5, which is 0. So, yep. Okay. Multiplication, if you multiply a positive number by a negative number, you get a negative number. So if you did 5 times -1, that goes -5. And if you multiply a negative number by a negative number, you get a positive number. So -5 times -1 is equal to 5, positive 5. Same thing for division, exact same thing. If you divide a positive number by a negative number, you will get a negative quotient. So 5 divided by -1 is -5. If you divide a negative number by another negative number, you get a positive quotient. So -5 divided by -1 equals positive 5. And that makes sense because -5 times -1 equals 5, and 5 times -1 equals -5. Remember, you have to be able to do it backwards. That's the definition of multiplication and division. And so, like I said, just know for multiplication and division, when you multiply or divide by two negatives, you'll get a positive number as your result. So, yeah. All right, exponents and exponent rules. So remember the exponent form. So a to the n, where n and a is the base, you're the base, and n is the exponent. And this just tells us that you multiply a by itself n times. So if n equals 1, then a. If n equals 2, then you get a times a. If n equals 5, then you get a times a times a times a times a. So 5 times. So that's the definition of an exponent. You multiply the base by itself n times based on what n is. Yes, you can have decimal exponents, but I don't know how to calculate those by hand. I think you need a calculator. But you can have decimal exponents. You can. That's possible. Anyways, also recall the exponent rules. So remember, first two is a given. You should just know them straight off the bat. Just look at them. Anything to the 0th power is 1 except for 0. 0 to the 0th power it's up for debate. It can either equal 1, either equal 0. It can either be undefined. So don't do 0 to the 0th power. Up for debate. So that's why I assume a and b are non-zero. So anything to the 0th power that's not 0 is 1. Anything to the negative power is just a reciprocal. So if you had 2 to the negative 3rd power is equal to 1 over 2 to the 3rd power, which equals 1 over 8. Now, likewise, if you had it on the bottom, that sign means exponent, like that. The caret sign, is exponent. But when we have a question with the answer that is 0 to the 0th power, what do we do? You're not gonna ever have an answer or a question about that. You're not gonna ever have that. I forgot there's two different ways to prove both because both are perfectly valid. You can say either 0 or 1 is perfectly valid. There's two different proofs for that. And so we call it undefined. Why? I think one way is to do it graphically. You can graph both and prove that it's both 0 to 1, 0 and 1. And there's also another proof where, there's another proof where, so if 2 to the 4th is equal to 2 times 2 times 2, right? And then you divide by 2, so you get 2 to the 3rd is 2 times 2 times 2. I think I can prove why anything to the 0th power is 1, but I can't prove why 0 to the 0th power because you can't divide by 0. So I divide by 2 to get 2 to the 3rd, right? Then 2 squared is 2 times 2, right? Then I divide by 2 again to get 2 to the 1st is 2. And then when I divide by 2 again, 2 to the 0th equals 1. So that proves why anything to the 0th power equals 1. But then if I had 0, right? If I made this 0, you get into a big no-no because you can't divide by 0. You can't do 0 divided by 0 anyways. So like 0 to the 4th is 0 times 0 times 0 times 0. And then if I divide by 0, well, dividing by 0 is already a big no-no. The fact that dividing by 0 is already a big no-no is bad enough. And so assuming that I could divide by 0 and cancel out the 0, if I get 0 to the 1st power, you would get 0, right? And then if I want to go down to the 0 to the 0th power, I have to divide by 0. This doesn't equal anymore. I have to divide by 0, and you can't do a 0 divided by 0. That's a no-no. That's undefined. That's a big no-no. So that's why 0 to the 0th power is also undefined. But yeah, they proved that you can prove that it's either equal to 0. You can also prove it's equal to 1. But then you can also prove that it's undefined because 0 divided by 0. I hope that clears it up. The graph method. I don't know exactly. I don't think I know. I don't know the graphing method exactly. Let me see. I can give you a video about it, I think. There's a good video about it. A really good video. Let me see if I can find it. There you go. Okay. It's a good video. So I will post it out to everyone. But it's a good video. It's a really good video. Chat to everyone. This video proves, I think he does, I think Black Pen, Red Pen, you should watch Black Pen, Red Pen when you get older, because he does a lot of calculus stuff. He proves that it can either, you can graph either 0 to 0th power equals 1 or 0 to 0 power equals 0. I think he does like a graphical method, but he does say that 0 to 0th is undefined. My proof is a lot more simpler and a lot more cleaner to understand, but the graphical proof is also valid. But yeah, my proof makes sense too, because like I said, in order to get from like 2 to the 3rd down to 2 to the 0th, you keep dividing by 2, right? But if you want to get to like 0 to the 3rd, 0 to the 0th, you divide by 0. But dividing by 0 is already bad enough. But then when you get to the final step of 0 to the 0th, or 0 to the 1st, which is equal to 0, and then if you want to go down to 0 to 0th, you have to divide this 0 from 0 to the 1st by 0. And dividing 0 by 0 is already big no-no. It's already undefined. So yeah. Okay. Where was I? Right. So first two rules of exponents should be given. Product property of the exponent. So if you have the same base, remember you have to have the same base. You just simply add them together. So 2 squared plus 2 to the 3rd, or times 2 to the 3rd, sorry. Times 2 to the 3rd is equal to 2 to the 5th. 2 plus 3 is 5. So you just add the exponents together. Fourth rule, same thing, basically the same concept, except when you're dividing and they have to have the same base, you just subtract the exponents. So this equals to 2 to the negative 1, or 1/2, or 1 over 2. So 1 over 2 to the 1st. Fifth one, I don't see this very often, but remember, if you have a power to a power, you just simply multiply it down. So if you had 2 to the 2nd to the 3rd, that equals 2 to the 6th. Likewise, if you had 2 to the 2nd to the x power, that equals 2 to the 2x power. That's totally valid as well. Product property, I don't see this very often, but it's kind of like distributive property, if you remember that. If you have two different bases and two different, like they're multiplying each other by each other, then you could distribute the exponent onto it. So if you had like x times y to the 2nd power is equal to x squared times y squared. I don't see that very often, but I guess it's good to know. It's good to know. And same thing, you can also distribute the exponents if you have two different bases being divided. So if x over y quantity squared is equal to x squared over y squared. So yep. So remember, these three are super duper important. The first two are given, and these two are just known. It's good to know for algebra, but not necessary. Might be necessary actually. But yeah, know these two at least. At the very least, if you don't want to learn them now, know these two at least, so that it's just given in your head. And then these three you can practice and study later. Number 3, 4, and 5. So yeah, what is quantity? Quantity means the amount, but when you're talking math, if you want to say quantity, you want to say something inside a parentheses squared, like x plus 1 quantity squared. Because if you just said x plus 1 squared, people might think this, right? So when you say something inside a parentheses, like a certain expression within the parentheses, you say quantity and then to whatever power, or just quantity divided, I don't know, anything like that. Like I said, if you said like x plus 2 quantity squared, they would know x plus 2 parentheses squared. But if you said x plus 2 squared, they think that, which is x plus 4. Obviously not the same thing, because it's x squared plus 4x plus 4. So yeah, I think that's right. Yeah, that's right. Okay. There you go. All right, common factors and multiples. You guys know that factors are numbers that we can multiply together to get another number. A number is a factor of a number n if n divided by that factor leaves no remainder. That should be a remainder. Remainder. In other words, the factor must be an integer, and the remaining quotient must also be an integer with no remainder. Why is there no periods in this page? Because I made this literally 2 hours ago, so I was typing really fast. Dude, I am a slow typer. My words per minute is probably like 70 to 80, 90 on a good day, words per minute, WPM. I am a slow typer, man. I wish I typed faster. I might show you guys like how fast I type after this. I share my screen and like go on type racer or something. But I type slow, man. Okay, anyways. Multiple. So basically, if you had like, you think I type at 120? I wish I could type that. I type slow, man. I type very slow. I type 90 on a good day. So right. So let's say like a factor, for example, a factor of 6 is 2 and 3, because if I did 6 divided by 2, I would get 3, no remainder. And if I did 6 divided by 3, I would get 2, no remainder. So these two are factors, and also 1 and 6. Because you guys know 1 in the number itself is always a factor of a number. Multiples are numbers that are the result of multiplying a certain number a by an integer n, thus resulting where in n times a, where n is an integer. Remember that n can also be 1 for multiples, so make sure you include the number itself as a multiple. So for example, multiples of 6 would be 6, 12, 18, 24, and so on and so forth, because this is 6 times 1, where n is 1, 6 times 2, n is 2, 6 times 3, n is 3. If two or more numbers, and finally, if two or more numbers share a factor or multiple, then they are common factors or common multiples. And you guys already know this. You guys already know. And then greatest common factor and least common multiple. So after you find out the common factors between two or more numbers, the largest of those factors is the greatest common factor. And likewise, if you find out the common multiples between two or more numbers, the smallest of those multiples is the least common multiple. So let's say like, I don't know, what's easy? 6 and 9. Yeah, okay, 6 and 9. That's a bad joke, whatever. Okay, so the factors of 6 is 1, 2, 3, and 6. I did not do that on purpose, by the way. They just are both divisible by 3. And the factors of that is 1, 3, and 9. So the greatest common factor is 3, because they both share 3 in common. And the biggest is 3. Those are share 1, but 1 is not the greatest. And the same thing for multiples. So 6, 12, 18, and this is 9 and 18. So the least common multiple is 18. Just a really quick example. Because 9 times 1 is 9, 9 times 2 is 18, 6 times 3 is 18. Yep. All right, prime numbers and prime factorization. So a prime number is a number with only two factors, one in the number itself. So example, 2 is a prime number because it's only 1 and 2 are the only factors of 2. And thus you could prime factorize a number by breaking down a number into its factors and then further breaking down those different factors until they are prime, making a number the product of all its prime factors. So prime number, sorry. For example, prime factorization of 96 is 2 times 2 times 2 times 2 times 2, or 2 to the 5th times 3. Because 2 and 3 are both prime, this is perfectly valid as a prime factorization. And when you start prime factorization, you can either start with 2 times 48, or 4 times 24, or 3 times 32. Whatever factors you like, you can start with either. So if I were to show it out, 96. So let's start with 8 and 12, right? So you have 8 and 12. And so since 8 and 12 aren't prime, you can keep going, keep breaking it down. So the factors of 8 is 4 and 2. Factors of 12 is 6 and 2. 2 is already prime, so you can keep as is. But 4 and 6 are not prime, so you can keep going. 2 times 2 is 4, factors of 4. And 2 times 3 is 6. So those become the factors of 6. So then you have 1, 2, 3, 4, 5 2's. So 2 times 2 times 2 times 2 times 2, and you have 1, 3 times 3. And that's how you get the prime factorization. Just a little example of 96. Okay. Algebraic expressions and formulas. Oh, I didn't talk about formulas, huh? Okay, it's okay. A variable is any symbol that can be resemble a number or another expression. Usually it's another number. So like X is a variable, Y is a variable, star, heart, I don't know, this symbol, whatever this is, anything weird, that can all be variables as long as you rewrite it the same way. Bob is a variable. Yeah, if you specify that BOB is like one entity, because people might think it's B times O times B, but Bob could be a variable if you specify that Bob is one entity. So say like Bob equals 3, and so you have like 3 Bob is equal to 9. That could work. But yeah, so variable, any symbol or letter. Letters are technically symbols. Any symbol, letter, shape, triangle could be variables, circle, ice cube, I don't know, a cube. Yeah. So an expression is like a mathematical sentence, consists of at least one operation and 2 numbers or variables. So 3 plus 4 is an expression. There's no equal sign, because if there was an equal sign, it'd be an equation. There's one operation, the plus, and there's 2 numbers, 3 and 4. An algebraic expression is basically a regular expression that includes at least one variable. For example, 4a divided by b has 2 variables in it, so at least one. It's 2 variables, 2 operations, division and multiplication. 4 times a divided by b. 4a divided by b. And has no equal signs in it. There's no equal sign. So, yeah. X plus 2 squared is quantity squared is an expression. Yep, that's true. Now, if you did x plus 2 quantity squared equals 0, which you could solve for, then that would be an equation. Or is an equation because people often assume c equals 0. It's an equation because often it's an expression formally, but since people are lazy and they don't write equals 0, it's technically an equation. But if you don't write the equal sign, then it's an expression. But since you assume it's equal to 0, then you just say it's an equation. Why what, Zoe? What are you asking? You just type y. You just type y, Zoe. I didn't. Why what? Why is Gamora? What is Gamora? When there is no equal sign in an expression. That's just the definition of it. Because an equation is 2 mathematical expressions, equal to each other. Remember the word equation. If I spell equation out, equation, it has the word equals in it. Equa, and you have equals. Right? The word equations has equals in it. And so equations require equal sign. And if it doesn't have an equation, the definition, it just becomes an expression by definition. So that's why. All right, let's move on. Solving one variable equations equalities. So you got to use the properties of equality to isolate a variable, and also you got to isolate the variable when you're solving for equations and inequalities. So let's do an example. I don't know, like 4x plus 3. 4x plus 3. Okay, we'll do 4x plus 3. What is the properties of equality? What you do to one side of an equation, so equals, let's say 7. What you do to one side of an equation, you have to do to the other side. That's the property of equality. Now, no one ever says that, except for like 3rd grade math, but then they just say it and then no one cares about it because yeah, example, yeah. I'll do an example real quick because like you have to do it. It just becomes like once you practice it enough, you just know it, and no one says properties of equality. Blah, blah. No, they just say like just do this, do that. So yeah. Okay, I'll do an example. Don't worry. So in order to isolate a variable we're trying to solve for, you have to undo all the operations. Yeah, exactly. See, anyone's never heard of properties of equality. See, they just say it, but then yeah, no one ever mentions it ever again. So don't worry about it. Okay, so right, where was I? To isolate the variable, you have to undo all the operations being done onto the variable, starting from the outside of the variable and to the inside of the variable. And remember, addition and subtraction are opposites, and multiplication, division are opposites. So let's take an example. 4x plus 3 equals 7. So we're trying to solve for x, right? Solve for x. Remember, x is the most common variable, at least in maybe in math in general. Yeah, I think internationally, x is the most common variable. My voice is dying out. So 4x plus 3. So when I say we have to undo all the operations being done, starting from the outside, notice that plus 3 is on the outside of x. So since we're adding 3, we have to subtract 3 to cancel this out. Because positive 3 minus 3 is 0. But since we subtracted 3 on the left side, the property of equality says we have to do the same thing on the right side. So we also have to subtract 3. Right? So then you get 4x equals 4. 7 minus 3 is 4. And now whatever doing on the inside of the variable, 4 is being multiplied by x on the inside. Then you have to divide by 4 because 4 times x, multiplication and division are opposites. So then you cancel this out because 4 divided by 4 is 1. Remember, when you cancel with multiplication division, you want to get 1. When you cancel with addition subtraction, you want to get 0. And since we divide by 4 on the left side, we also have to divide by 4 on the right side. So this also turns into 1. So then you get x equals 1. And then you can check it by plugging in x to your original equation. So 4 times 1 plus 3 equals 7. And you see 4 plus 3 is 7, which is indeed true because 7 equals 7. You cannot tell me otherwise. You cannot tell me otherwise that 7 does not equal 7. Have you guys heard the proof that 0.999999 repeating is equal to 1? Or 9.9999999 equals 10? Actually, I've never heard the 9.999. Never mind. I've only heard this one. 0.999999 equals 1. What the heck is this? Yeah, it's a good proof. It's a good proof. Okay. And then last note, when you solve for inequalities, so inequalities, remember, have these signs. I've never seen that does not equal 2. Anyways. Remember, when you divide by -1, you must flip the sign. So if you have negative x is less than 3, technically that's not your solution because you haven't isolated x yet, because this is equal to -1 times x is less than 3. You divide by -1 to get rid of the negative. Negative goes away because negative divided by negative is positive. I've never heard that proof before, but that's pretty good. I've never heard that one before though. Yeah, I've never heard that one before. That's pretty good. I've heard 2 ways of doing it. Anyways, I'll talk about it later, maybe. So, right, -1, then you divide by -1 here, because properties of equality. So then x would be greater than, you have to flip this less than sign, greater than -3. So that'd be your solution. Area and volume, you guys know area. 2-dimensional measurement shows us the amount of square units we can fit inside a 2D shape. No gaps are overlapping. Area units are always squared, as in units squared. Volume is 3-dimensional and shows us the amount of cubic units we can fit inside of a 3D shape with no gaps overlapping. And also, volume is always units cubed. So that should be an A. Area equals units cubed. Volume equals units, or sorry, area is units squared. Volume is units cubed. And 2D shapes versus 3D shapes. If I drew like a cube out, that's a horrible looking cube. Versus a square. Look at that. What do some people write area as S? I've never seen area as S. I mean, honestly, if you just know what you're solving for, it doesn't matter what you write it as. Right, surface area is the area of all the faces of a 3D shape. So it's the sum of all, and you can usually find it through a net of a 3D shape. I should erase that. or by visualizing the surface of your 3D shape, be taken out, and then you lay it flat, and then you take the area of each individual face and you add it up. And they're always units squared because it's surface area. So for example, if I had a cube, now I can either visualize it as 6 squares, because it's 1 square, 1 square, 1 square, 1 square, 1 square, 1 square on top, 1 square on bottom, 1 square on this front side, 1 square on the back side. There's 1 square on this side right here, and there's 1 square right here. So it makes a total of 6 squares. What's the net of a sphere? What is the net of a sphere? I forgot actually. Oh, that does make sense. It looks like this. Looks like that. That's the net of a sphere. Because when you take the sphere, it's the net of a sphere. Remember, a net is like, so if I had a cube, I can draw a net like this, as in 6 squares like that. And this is your net. This is a net of a sphere. Because how many of those things? It depends on the size of the sphere. Example. Because then if you take this, if you take one section out and you peel it like an orange, out like that, you get something like that. So yeah. Okay, independent and dependent variable. So an independent variable is a factor in an experiment or problem that drives the problem. It's also a variable that is being manipulated or changed around. Likewise, a dependent variable is a variable that depends on the value of the independent variable. Go figure. You cannot determine the quantity of the dependent variable without knowing what the value of the independent variable is. So remember back to my lesson with that, about the ship example. So if you destroy one ship, or every ship you destroy, you get 10 points, right? Well, you don't know how many points you're going to get if you don't know how many ships you destroyed. So the points in this case would be dependent, and the ships would be independent, right? Independent. And that makes sense, right? Because you don't know how many points you get, because the amount of points you get depends on how many ships you destroy. And a rule of thumb, when you graph the independent variable, goes on the x-axis. So independent, and the dependent variable goes on the y-axis, dependent. All right, some graphing stuff. You know the coordinate points go in the order of x, y, where x coordinate goes first. So you look at x and then you go y. So right here, x, y. The slope of a linear line, linear means straight, determines how steep that line is and what what direction the line goes. So the greater your slope, remember slope formula is m. It's called m. Is equal to y2 minus y1 equals x2 minus x1, which is also equal to, it's also equal to rise over run. And so you have to have 2 points in order to find slope, obviously. You need to have 2 different points. So yeah, the greater the slope, the steeper the graph is. So a steep slope would look something like that, like really high. And the smaller the slope, something like that. It's not that, it's almost flat. What is up with run? What do you mean run? Run is basically the change in x over change in y. Oh yeah, I haven't taught you guys delta. Oh, I forgot to teach you guys delta. Delta, this triangle is called delta, which equals change in. It's called change in something. And notice that when you have a change, you always have a subtraction. It's always subtraction. So if you take like physics, for example, change in velocity is equal to acceleration. I hope that's right. No, that's not right. Whoops. Change in displacement. There you go. Change in displacement, delta x is equal to your velocity times time. But it also is equal to, technically, it's equal to your final velocity minus that. That's what delta x equals. So this delta means change in, just change in delta, this triangle. It's called delta. So rise over run is the change in vertical distance. So if I had this graph right here, let's make it green. The change in, let's say from this point to this point, the change in vertical distance divided by the change in horizontal distance this way, right? So if I make this graph bigger, if I could, let's get black screen. I had this line right here. The slope, and I had these 2 points right here. So the slope would be change in y, so change in your vertical, change in your rise, so delta y, and then change in x, change in your run, or sorry, change in your horizontal direction or your run. So this is rise, this one's run. Notice that also creates a right triangle. That's not coincidental, by the way. Because then you have something called the distance formula. I don't know if I remember it right. Uh-oh. Do I remember the distance formula?
Isn't the distance formula like the Pythagorean theorem?
Yeah, it's exactly, that's why it's not a coincidence. This is a right triangle. Y2 minus y1, there you go, squared. Yep, so this is your distance formula, which literally tells you the distance between these two. So this is slope. M equals delta y over delta x, or rise over run. And yet, like I said, not a coincidence that it forms a right triangle. Not a coincidence. It's distance formula. Because if you say this like side is d, that's delta y delta x. I think d squared is equal to delta x squared plus delta y squared. And since we proved that delta x equals x2 minus x1, and delta y, the change in y, is equal to y2 minus y1. Remember, change always has to have subtraction because you're changing. Then you can just plug it in, plug these two in, and then take the square root, and you would get this, like that. So yeah, not a coincidence. Okay. But you don't need to know that now. This is 6th grade math. That's like a couple years down. This is for now. And this is from yesterday's lesson. We're almost out of time, so I don't know if I want to go over this. This is not too important. Frequency tables. This is important though. Okay, you should know this. Right, normal distribution or the bell curve looks like this. Kind of something roughly like that. Maybe like that is better. I'm doing 7th grade math at a school. What do you mean a few years young? You don't learn distance formula until maybe 8th, 9th grade math. So that's technically a few years. Few is 1 to 3. Couple of years. Technically, maybe 9th grade. You don't learn distance formula, especially with the new Common Core. You don't learn distance formula until like 9th grade math, I think. But since I'm guessing you're advanced, you'll probably take it next year. Because it's called like Math 1. I don't know how it works. Don't ask me. Right. So this is normal distribution. Normal. Everything is in the center. So your mean, median, and mode are in the center. So in a perfectly normal distribution. You learn outside school. Oh, good job. The mean, median, and mode are located in the exact center of perfectly normal distribution, which is 99.9% of the time in the real world, never going to be this way. Maybe there might be that golden egg, that lucky coincidence. Very unlikely. Anyways, remember, skewed left, skewed right, you should know. So remember, skewed left means that majority of data is located on the right side, and there's a tail on the left side of the data. So these two ends, so a tail is like the end of your graph. That's what a tail is. Is there an easy way to do mean? Not that I know of. Get a computer, get a calculator. That's the easy way. Get a computer, a program, AI program for you to do it, code a program. Go online, look up mean calculator. That's the easiest way. Do it by hand? No, there's no easy way that I know of. All right, so skewed left means majority of the data is located on the right side, and there's a tail on the left side. So notice this end is on the left side right here, and a lot of the data is on this right side. So this is skewed left. I should make that into red. So this is tail right here, on the left side, and a lot of the data is on the right side. Skewed, wrong way. Skewed right means that everything is on the left side. Majority of your data is on the left side, and there's a tail on the right side. There's a little tail right here on the right side. So this is skewed right. So like I said yesterday, you can think of it either as the opposite. If most of the data is on the right side, you think opposite, skewed left. If most of the data is on the left side, think opposite, skewed right. Or you just look at the tail direction and just say correspondingly. So if the tail's on the left, skewed left, tail is on the right, skewed right. And you don't need to know this, but in a skewed left distribution, the mean is expected to be less than the median because of these outliers on the tail. It lowers your mean for skewed left, skewed left. Because outlier on these tails, it lowers your mean, right? Because when you go move to the right and move up, so that's part of CP, right? What is CP? Let me redraw these actually. Counting and probability. Yeah, counting and probability is part of stats. You should say that rather, because stats is huge. It's a big field. Even I don't know that much stats because I took calculus in high school. And so in a skewed right distribution, the mean is expected to be greater than the median. So if I visualize that, so if you had your skewed left and you had your skewed right, remember the median is the center. Now, because there's a lot more data points on this right side, you can expect the median to be somewhere like around here, right? Towards the right. But because of these points right here are less than the points on the right, they're going to drag down your mean. They're going to drag down your average, make it lower. And so your mean would probably be lower than your median. So this is mean right here. And this is median on the right side. And same thing for this graph on skewed to the right. Now, because it's more towards the left, your median would probably be somewhere here towards the left. And because there's more points on the right that bring the average up, because these outliers right here, you're going to get a higher mean. So mean is going to be greater than the median and is skewed to the right. And that's it. I think that's it for today. Yep. That is it for today. So you guys are free to go unless you have questions. That's the last lesson. You guys have been great. I hope you guys learned something new at least one thing. Even if it's not math, I hope you guys learned something. But yeah, the proof for the 0.99 thing, you guys are free to go. You don't have to stay for this, but proof for 0.99, I should go there, is equal to 1. One proof I had is if you set 0.999 to something like x, and then you multiply this by 10, right? 10. This would be 9.999999 is equal to 10x. Right? Yeah, that thing. Why was there not much Kahoot? Just cause. Are you gonna make boy? Are you trying to make the man's boy? Huh, Donald? Trying to make the man to threaten me? Okay. So you have 9.99999, right? Because you multiply by 10. Or sorry, this way. Whoops. I am hungry. And then you simply subtract x because x is equal to 9999999. So you subtract this, so you get 9x equals, this goes away, 9. And then you just prove that x equals 1. That's one proof I see. Another proof is, you know that 0.3333 is equal to 1/3. 0.3333 is equal to 1/3. And 0.3333 is equal to 1/3. If you add this all up, you would get 1, or 3/3, right? And this would become 0.9999999 is equal to 1. So that's how you prove 0.99999 equals 1. I'm repeating myself. I don't know if it's a pun, is that an insult? But hey. So that's one way. These are two ways to prove it. You either do the mystery algebra way, where you multiply by 10 and you subtract by 1x to cancel out the decimals, and you get 9 equal to 9x, and then you solve for x, which equals 1. Or you do the 1/3 decimal way, because you know that 0.33333 repeating is equal to 1/3. And if you add that 3 times, you get 1/3 plus 1/3 plus 1/3 because it is equal to 3/3, which is 1. And if you add the decimal part, you get 0.99999 repeating is equal to 1. So thus, 0.99999 equals 1. If you're not convinced by this way because you already set x to equal to this part, then I think this is more convincing in my opinion. But yeah. Other than that, you guys are free to go unless you have questions, which I don't know.
I have a question. At last class, we forgot yesterday's class. And what yesterday talking about? It taught statistic.
Statistics. Yeah. So it was about basic statistics, about like frequency tables, dot plots, histograms, and skewed left to the right, skewed left, skewed right, and normal distribution.
Okay. Do we have a document? Can you share the documents, or is not cannot be shared? I'm not sure.
We'll see. I guess give me an email or something. We'll see.
Okay.
Try give me your email. I'll share.
Okay. Thank you very much. Okay, thank you. Okay. Thank you very much. The kids really like your lesson, the class. Yeah.
Okay. Any other questions? Anything? This is the last class, by the way, so don't come next week. If you come next week, you're not gonna find anything. Nope. Bye. Okay. See you, Jingwen. Mom's email, BlackBerry. Something at your okay. Let me get onto that. You're also a slow typer. Like how slow are we talking here? Like, what's your WPM rather? You also hungry? Bye. What? Well, he just left. Okay, I'm not sending it to him. He just left. All right. Any other questions or anything? Otherwise, no. Otherwise, I'll just end the thingy, end the lesson. The last final lesson. Thank you for sharing your surface class. Thank you. Oh, thank you, Cloud Classroom. I mean, yeah, it was great. This was fun. Obviously, I'm gonna send it to him. This was kind of fun. It's a new experience for me. This is my first time teaching, so definitely a new experience. I hope you guys had fun. I hope you guys learned something new. Like I said, at least even if it's not math related, something new at least. Yep. Take care as well. Keep in touch. Yeah, sure. I still have your guys' email. Yeah, see, class starts soon for me, October 1st. Good luck for my college. Oh, thank you. Is the last class? I thought there were 2 more next week. Bye, Cloud Classroom. I don't know who you are, Cloud Classroom, but yeah. This is the last class. Yes, there's no more Zoom calls. Do not come next week. If you come next week, you're not going to find anyone or me, at least. So yes, today is the last one. No other questions. I will end it. So going once. Give you 2 minutes. I'll end it in 2 minutes, unless I get a question. Can you explain mu again? Oh, mu it's nothing. Mu is just a variable. It's just a Greek letter. It is just a Greek letter. I'll look it up for you. I have a. Let me share my screen. Hold on. Okay. So this is mu. It looks like this. Looks like kind of like a U, but you can also kind of see it like an M right here. This is mu. See, looks kind of like an M, but also looks like a U, but looks like an M. Called mu. It's 12th letter of the Greek alphabet. Yeah. It's used in stats. Like if I look up mu, Greek letter, statistics, look at that. The third result is statistics because it's used in statistics. See, mu, so if you have x bar is equal to mean. This means mean, right? You see that? So x bar looks like this. X bar, this is u, which is equal to mean. So yeah, that's mu. It's used in stats. It's just a variable. It's a symbol. In physics, you have the kinetic constant mu Fk for friction, or mu Fs. This is kinetic friction for physics, friction. And this is static friction. Yeah, you're not supposed to because no one has a Greek static friction. Nobody has a Greek keyboard. It's called mu. Just type in mu, mu. That's how you spell it and pronounce it, mu. You're not supposed to type it because we have all English keyboards or Latinized keyboards, not Greek. But yeah, like look, I'll look it up for you. Like, look, mu Greek letter friction. I spelled friction wrong. Friction. The coefficient of friction is assigned Greek letter mu, and it's unitless. Look at that, see? So mu has lots of uses. It's just a symbol. That being said, let's see how fast I type, because I type really slow. Type racer. So how fast do you guys type? This is a good site to practice your typing. It's a really good site. So frightened. This is just a passing phase, just one of my bad days. Would you like to watch TV or get to treats or contemplate a silent freeway? Like to see, I don't know if you can hear me typing. I fat fingered. Oops. Do you think it's time I stopped? Why are you running away? I fat finger a lot. Say 82. It's pretty slow. Use nitro type. Okay, you can use nitro type, but don't use the nitros in nitro type. Because the nitro type is basically cheating. You're skipping big words you don't want to type, then you're not. Okay, good. Yeah. Nitro type works too. I use type eraser. Nitro type works. If you use the nitros and nitro type though, if anyone, like people who tell me I use nitro type and I say, do you use the nitros? And they say, yeah, then I just look at them in disgust. I'm like, shame on you. You don't even know how to type big words. You don't want to type big words. Because obviously you can get 120 words per minute typing small words, and then you just skip the big words with nitro. It's like, what's the point of typing then? So yeah, it's good that you don't. All right, any other questions? Any other questions? Otherwise, I'll end it in 1 minute. When it hits 16 on the clock. Should I give it to him? I don't know. He just left for no reason. I guess this. Thank you for teaching us. Bye. Oh, no problem. Yeah, no problem, Gloria. Hey, have a good one. Take it easy, okay? I know you guys are little kids, but hey, enjoy it while it still lasts. Enjoy being a little kid while it still lasts. Goodbye. Okay, no questions. It's 16 on the clock, so I'm going to end it. You guys have been amazing. You guys have been great. Thank you, guys, for being great students. I hope you guys learned something in this class. I hope you guys enjoyed the class. I will not see you guys, unfortunately, but this was definitely an experience. So thank you, guys. All right. Bye.